Hello, okay, so we're going to do Calculus 1.1. I'm going to try to make it a little bit speedier than my usual slowness. Chapter 1.1 is all about finding or rationalizing denominators, and it's an important thing to learn for limits coming up. Keep in mind that in math, you always want to build on top of the pyramid and learn how to do things. And it's usually related to the next chapter, so you can't really skip chapters. Also, the best thing you can do is problems. The more problems you do in the homework, the more you'll pass your exam. That's all there is to it. But let's look at what rationalizing the denominator is. Unfortunately, this number, which is very precise, ends up being a long decimal number. It's not rational. It never ends. The decimal goes on forever. And while what we like about a square root is that it's accurate, we would never use the decimal because we lose our accuracy. What we don't like is sometimes you don't want it on the numerator, and sometimes you don't want it on the, say 17, you don't want it on the denominator. So you have to learn what's called rationalizing the numerator or rationalizing the denominator. And all that means is if I have this, and I want to get rid of my square root 5 on the top, I'm allowed to multiply any fraction or any number by 1. And I'm allowed to express that 1 in any way I want. For instance, 9 over 9 is also 1. Well, it turns out that square root 5, which is this one I'm trying to get rid of, over square root 5 is also 1. So by multiplying this fraction by 1, I'm not changing it at all. I'm just changing the denominator. And so let's look at the top. When you're multiplying fractions, you just multiply the top. Well, you're going to learn that any square root times itself just ends up being the number inside of it. If you want to see the long steps of it, it's 5 times itself. So if you know your notation, 5 square root is the same as 5 to the half. And this is to the power of 2. And what can you do with exponents? You multiply the exponent times the exponent. You end up with 5 to the 2 over 2, which is 5 over 1, which is simply 5. So you can see whenever square roots multiply each other, they simply become the number or the unit that's inside. And that's true for even things like this. If I have x plus 7, and I multiply it times x plus 7, it simply becomes x plus 7. So that's the square root of x plus 7 times the square root of 7. X7 simply becomes the number inside. And you're going to learn all sorts of complex ways of getting rid of things. You're also going to have to face situations where, well, let's go back to this first. So what happens when I multiply the top? I get 5. And what happens when I multiply the bottom? Well, they can't resolve. So you just leave them like this. And that's the most accurate. But you'll notice we no longer have a square root at the numerator, and that's what we want. So let's do the examples. There's one other thing I want to go over. Sometimes you're going to have a situation like this as the numerator or the denominator, doesn't matter what. To get rid of a square root like that, when it has something added or subtracted to it, you multiply by what's called the conjugate. The conjugate. And the conjugate is the exact same items, so square root and 3, but whatever symbol is here, you do the opposite. What we learned in the difference of two squares. The difference of two squares is that when you do this, the middle terms disappear. So if in doubt, expand it. So what's square root of 5 times square root of 5? It's that. What's square root of 5 times plus 3? It's that. What's negative 3 times the square root of 5? It's that. Now notice the middle terms are going to just zap each other. And finally, what's negative 3 times plus 3? It's negative 9. So these two terms get rid of these. You're left with 5 minus 9, which can be resolved. But hang on, I want you to notice something. What we're left with when we multiply two conjugates is we're left with the square of the first number minus, always minus, the square of this last number, and the middle terms disappear. And that's the whole point of a conjugate. So knowing that, let's have a look. They just want us to write the conjugate for this one. So what's the conjugate of this one? Well, let's start by putting it in brackets. The conjugate of this one is simply the same terms with an opposite symbol in the middle. There we go. When this multiplies out, we're going to get 4, and it's going to be 3 left over, and then minus, we're going to be left the square of that. This can be resolved to 12 minus 16. 12 minus 16 is minus 4. So you can see, as soon as you learn the conjugate rule, it's very easy. But this is going to be a very important skill to have for your limits. Now, I'm going to do one more, and then you should always see if you can do them. So the first thing, put brackets. Next, the second, what's the conjugate? It's going to be the same terms, and then the opposite symbol in the middle. Great. The two terms will disappear in the middle, and we're going to be left with this. This is the square of the square root of 2, and this is the square of square root of 3. 3 minus 2 is minus 1. So the next ones look complicated. I'm going to do one more, because it's very important in math to do the practice work yourself. That's how you ingrain it in your memory, and that's how you learn. There's no way around it. Watching somebody do it won't work. So we have to make the symbol in the middle here opposite. And now just be careful. This minus outside the square root of 5 times the minus outside the square root of 5 will make a positive 5. And this plus 2 times the negative, so it's always going to be negative. It's going to be negative 4 times 2. And that's going to be plus 5 minus 8. That's what you're going to end up with, which is minus 3. But you'll see this minus here affected the outcome of this 5. Well, actually it didn't, because a minus squared is always going to be positive. But just be careful. Now, they're asking you to rationalize either the denominator in this one each time. So don't get confused about what they're asking for. The denominator, of course, as you know in fractions, is the bottom. So what's the easiest way to get rid of square root of 2? Multiply it by square root of 2. However, I'm not allowed to change this fraction, but I am allowed to multiply it by 1. So that's what I multiply it by. So let's multiply out the bottom. The denominator is simply going to become 2, which is what I want. This is going to become square root of 6 plus square root of 10. And yes, square root numbers can multiply each other so long as you keep them inside the brackets. Now, there's no simplifying these, so boom, they're left like that. You could also write it like this if you needed to for whatever reason. Now, please note the 2 cannot be divided into the 6 because it does not relate to that. They're not the same number. This has a power of 1 over it, and the 6 has a power of a half to it. Since they don't have the same base, you cannot divide them. Okay, so just keep that in mind. Don't try to simplify inside a square root from a whole number. So that's the final answer, or that's the final answer, and that's exact. I want you to have a look at what you think you have to multiply this to get rid of the denominator. Well, interestingly enough, I don't have to multiply it by 2 times the square root of 3. I only have to multiply it by the square root of 3 over the square root of 3. Okay, what's going to happen at the bottom? I'm going to get 2 times the square root of 3 squared, which is 2 times 3, which is 6. What's going to happen at the top? Well, this is going to multiply out through these. Now notice here, it will get rid of it. It'll be 4 square root of 3 squared plus 3 times the square root of 2 times the square root of 6. Sorry, square root of 3, like that. What's 3 squared? It's going to be 4 times 3, or sorry, square root 3 squared is 3. So it's going to be 4 times 3 plus 3 square root of 6, which is square root of 2 times square root of 3, all over 6. What's 4 times 3? It's 12 plus 3 over square root of 6. Now, it's conceivable that you could simplify both of these. This has a 3 in common, and this has a 3 in common. So you can factor out a 3 out of both. You get 4 plus square root of 6 when you do that, all over 6. These can now simplify because you have a number times something divided by a number. So these can simplify, and you're left with 4 plus square root of 6 up top, all over 2. That's what happens when these simplify. You get rid of this 3, and the 6 becomes a 2. So this is the simplified version. You could also write it as this if your teacher wanted, but in some cases you want to simplify even further. So you see I've put the fractions on their own base, and 4 divided by 2 is 2. So it's conceivable you could write it like this, or write it like this, but these are both the simplified forms. And notice a lot happened to the numerator. So don't just assume the numerator is just going to be one big mess. It can simplify as well. And you're always trying to simplify a fraction. Yeah, I don't think you need my help to do the next ones. Now they're going to ask the denominator again, but clearly they're making the denominator a bit more complicated, and you have to come up with, what did I say before? The conjugate. So the conjugate is just simply the opposite item. So you simply make this, you make 2 copies, and you make it a fraction. But what are we going to do with the symbol in between? And we might as well put it in brackets as well. We're going to multiply it. But what are we going to do with the symbol in between to make it a true conjugate? We're going to make it a positive, the opposite symbol. Okay? So I know from my conjugates that the middle terms are going to disappear, and I'm going to be left with 5 minus 2 at the bottom. That's going to be the bottom. You go ahead and expand it if you want. The middle terms are going to disappear, and it's simply going to be this number squared minus that number squared. So square root of 2 squared is 2. Square root of 5 squared is 5. So that's what I'm going to be left with. Practice those. They'll become clear. What about the numerator? Well, you're left with 3 square root of 5 and plus 3 square root of 2. But before I do that, let's just leave it as is. Square root of 5 plus 2. And what's the denominator? What's 5 minus 2 become? It becomes 3. Now, we have 3 times something divided by 3. So what is 3 divided by 3? It's 1. So the answer to this, sorry, I forgot a square root here. The answer to this is quite simply square root of 5 plus square root of 2. This cannot be added. They're not the same base. You can only multiply square roots, but they cannot be added. You can only add square roots that have the same base inside. All right, so that's the final answer. Let's do another one. Okay. Let's do the last one. We're trying to, let's go to here. They usually put the more complicated ones last. So in this case, remember, they only want you to rationalize the denominator. So don't worry about the numerator. But interesting things are going to happen in this one, I think. So how do you rationalize the denominator? Well, you take the same thing, over top the same thing, and you change what? You change the sign in the middle. So I'm going to just steal this sign here. You change the sign. There we go. Boom. Put it in brackets just to make everything clear for yourself. And remember that we're multiplying. What is this whole mess divided by this whole mess? Well, it's simply 1. You're multiplying by 1. Now, we know from experience, when I multiply 2 conjugates, I get the square of this number minus the square of this number. So the square of this first number is 9. It's 3 squared. Square root of 3 squared is times 3. Then I get minus, what's the square of 2? 4. What's the square root of 2? Times 2. So what's 9 times 3? It's 27. What's 4 times 2? It's 8. What's 27 minus 8? 19. So this whole bottom thing is going to turn into 19. That's going to be the numerator. And we can see that the numerator came out quite nice and clean, right? What about the top? Well, interesting things are going to happen to the top, too. So what's 3 times 3? Well, 3, this times itself. What's the same thing? It's going to be 9 times So it's going to be the square of that and the square of that. 9 times 3. Then what about this? Well, here you can multiply the whole numbers and you can multiply the square roots, but you can't mix and match. So it's going to be minus 6 square root of 6. And then it's going to be minus 6 square root of 6. Notice they have the same base, these two numbers, so you're going to be able to subtract them. And then the last one is just minus 2 times the square root of 2 times minus 2 times the square root of 2. It's going to become positive 4 times 2. So let's resolve our numbers up here. 9 times 3 is going to be 27. These two, what's minus 6? What if I said what's minus 6 minus 6? It's minus 12, right? And you just keep that as the base. It's like saying what's minus 6x minus 6x? Well, it's minus 12x. So this is minus 12 square root of 6. It's like adding 12 apples or subtracting 12 apples. We're left with negative 12 apples. In this case, our apples are square root of 6. Plus 4 times 2, no, that's 8. So clearly we can add our numbers together. What's 22 plus 8? 30. So we're left with 30 minus 12 square root of 6 over 19. Now 19 is a prime number. It can't be divided by anything. So there's no way you're going to simplify with the denominator at all. So that is going to be your final answer, assuming I didn't make any arithmetic errors. I do make arithmetic errors. If that had been 18, and if I made an arithmetic error, then so be it. But there's common numbers in all of these, and that would be 3. So I could divide this by 3. I could divide this by 3. And I could divide this by 3. 6. So I'd be left with, oh, and look, it could be divided by 2 more. So it actually could be divided by 6. They can all be divided by 6. So if I divided by 6, that's why I'm tempted to think I might have made an arithmetic error somewhere. If I divided that by 6, I'd be left with 5. And minus 2 square root of 6. And then the bottom one divided by 6 is 3. So if that had turned out as 18, that is what I would have been left with. But looking back here, I can see that it's going to be 27 plus 8, or 27 minus 8. So I'm quite sure I got it right. Okay, but anyway, that's how you can learn how to multiply by the conjugate, and then you will have to learn how to simplify. Now here's the next one. They're asking us to rationalize the numerator. Notice this numerator has a square root subtracted by a number, which means we're going to have to multiply by its conjugate over its conjugate. And we're not quite done yet. That's not its conjugate. This is its conjugate, the opposite side. Okay, so when I multiply this out, I know I'm just going to end up with the square of this number minus the square of that number. So up top, I'm going to left with 5 minus 1 at the top. What's 5 minus 1? It's 4. What am I going to be left with at the bottom? 4 times the square root of 5 plus 1. And the reason I didn't expand that is because I can already see that these simplify, and I'm left with 1 over the square root of 5 plus 1. And that's it right there. Now that could also be technically also written as, if for some reason you wanted to, 1 over the square root of 5. No, it can't be. My bad. That's as simple as it gets. I was thinking it's a numerator. And look how simple that became. You're essentially converting this fraction into a different fraction. This is still the same as that, believe it or not. If you take your calculator and you take square root of 5 and subtract 1 and divide it by 4, you'll get the same number as if you take 1 and divide it by square root of 5 plus 1. Yeah, it doesn't look the same. Numbers are interesting that way. You can convert them into different denominators, and they're still the same number. So here you can see 5. They're just giving you more complicated ones. Still the denominator, right? And there's ways that you can simplify it, but there's really no need to. You might want to, but I mean, there's a way that I could get 3 out of this, and I can get 2 out of that, but I'm not going to. So how do you rationalize the denominator? You multiply it by its conjugate, top and bottom. You're essentially multiplying by 1. But don't forget, you have to change its sign. Oops. Helps if you put it in the brackets. Now, I know from experience, if I multiply a conjugate, I get the square of this number minus the square of this number. What's 20 minus 18? 2. So the denominator is going to become 2. What's going to happen with the top part? All sorts of weird stuff. You're going to get 8 times the square root of 40. Actually, let's just leave the 8 out for now. And we're going to do just the square 8. We're going to leave the 8 square root of 2 out for now. And we're going to keep square root of 20 plus square root of 18 in brackets. And right away, oh, actually, you know what? Yeah, no, you can. We've got a whole number times the square root divided by 2. So that 8 can be divided by the 2 because it's 8 times the square root of 2 times whatever's this in this bracket. Those simplify. This 2 disappears. Up top, I'm left with 4 square root of 2 times the square root of 20 minus plus 18 plus square root of 18. Now, it's important to expand it because sometimes these can be resolved even more. When I multiply these, I can only multiply the square roots inside. So I get 4 square root of 80. Right away, there might be something in there. Plus 4 square root of 36. Now, what's the square root of 36? It's 6. Is there anything in here? 45 times 2. Are there any square roots in there? 49 times nothing? No. 10, no. 10 doesn't have square root. 3, you just got to look at, 4s. Oh, there's, 4 times 20. 4 times 4 times 20. So that's 16 times 5. Okay. This can be written like that. This is now can be written like this. What's 4 times 6? 24. Now, why did I break my 80 into square root of 16 times the square root of 15, which can also be rewritten like this now? Why did I do that? Because this has a natural square root. So it becomes 4 times the 4 in front times the square root of 5. What's 4 times 4? 16. So I'm left with 16 square root of 5 plus 24. These cannot be added together because they don't have the same base. It's like saying 16x plus 24. They cannot be added. So boom, there's the simplified version of this, and it's why this question has a star beside it. It's because it has an even simpler version of it. So again, multiply by the conjugate. And remember that the conjugate has to have the opposite sign. So always remember to put a plus sign there. 8 times that, so the number times the number. Oh, what's the bottom going to become? It's simply going to become the square of the first number minus the square of the second number. 20 minus 18. 2. So our denominator is simply going to become 2. What's going to happen to our numerator? Multiply your whole number and your square root plus your numerator. And actually, I probably again should have just left the, let's just leave the 8 out. 8 square root of 2. And leave the, we're going to leave the top value in the brackets. And notice that my 2 can simplify with my 8. So I'm really left with 4 and nothing on the bottom. So that top becomes 4 square root of 2 times the conjugate. So what's 4 times 2? 8 square root of 10 plus 12 square root of 2 times square root of 2 is what? 2. 12 times 2. So you're left with 8 square root of 10. Can't be simplified anymore. plus 24. There, you can see how it really simplified down. This fraction is the same as that fraction. If you punch this into your calculator and punch that into the calculator, you get the same numbers. And that's not really the point of it. The point of it is learning how to convert a fraction into something that's usable, and you'll see why in limits. Limits ask you to do it because sometimes the denominators aren't solvable the way they are. Then they ask you to go through it again with this. I'm just going to say that, oh no, we did that one. Then they ask you, oh, why are they the same? Okay, here's why. If you look carefully at these fractions, this fraction can be converted as square root of 4 times square root of 5, and this can be brought out as a 2. There it is there. This fraction can be written as square root of 9 times square root of 2, and this 9 becomes a 3, and the numerators are the same. So this square root this here is the simplified version of that square root up top. I wasn't even paying attention to that. Again, they're asking you to rationalize the denominator, and I'm going to just tell you it's always going to be the conjugate. And the conjugate's always easy to find. So I'm going to do one of these. They're all just number games, really. I'll do the most complicated one here. Okay, so we're rationalizing the denominator. So you take the conjugate of the denominator, and don't forget you have to change the sign. So what I'm going to steal this sign here. Use that sign. So the bottom, what the bottom becomes is the square of the first number, 18, minus the square of the second number, 12. What's 18 minus 12? 6. So the bottom is just going to become 6. What about the top? Square root of 18 times the square root of 18 becomes 18, plus 18 square root of 12, plus square root of 18 times square root of 12, and you're going to want to notice that this one can be simplified, so can this one. And you know what? Yeah, and then we've got it again. 18 square root of 12. So essentially we have 2 of them. So let's just take what we've written here and put a 2 in front of them. So that's what it is. And then the last one just becomes 12. Let's simplify this. What's 18 plus 12? 30. So let's change this to a 30. Now, for a second here, I'm just going to get rid of my question. And I'm going to expand this. And I want you to focus on these square roots right here and how they can be broken down. Square root of 18 is the same as square root of 9 times the square root of 2. Square root of 2 can't be solved, but the square root of 9 can. So it just becomes 3 times square root of 2. So this whole thing here can be replaced with that. And 12 is the same as square root of 4 times the square root of 3, which is the same as 2 times square root of 3, which means this here can be replaced with that. So what I'm left with up top is 2 times 3 square root of 2, that's the square root of 18, times 2 square root of 3, that's the 12. My 2 times the 3 times the 2 becomes 12. My square root of 2 times square root of 3 becomes square root of 6. So I can see that my top can just become that. And you might say, why? Well, it's simpler to write this than the long mess I had in. Now I want you to notice that the 6 can go into the 30, the 6 can go into the 12, and the 6 can go into itself. So this divided by 6 becomes 5, plus 12 divided by 6 becomes 2, and the 6 at the bottom disappears. Look how simple that is. So we've turned something with a complicated looking fraction into a very easy number. Now obviously in limits, what you're trying to do is get rid of the denominator sometime. This is a perfect example of getting rid of the denominator and being able to solve it. And the reason is that you're going to find in limits you can't have a 0 in the denominator, so you have to solve the situation where you can turn it into a fraction where you can solve it. That's the whole point of why we're doing this. just remember to simplify. That's the point. And the last one here, rationalize the denominator. Okay, so be careful here. They look harder than they are. Okay, so I'm going to do this one because it's probably important. So it's asking us to rationalize the numerator, actually, the numerator. So up here, what's the conjugate? Conjugate of that is going to be square of a plus 2 over the square root of a plus 2, because I'm not allowed to multiply by anything other than 1. Okay. When I multiply these, the top, when you multiply conjugates, simply becomes the square of the first number, a, minus the square of the second number, minus 4. What does the bottom become? A little bit more complicated. It becomes a times the square root of a plus 2a minus 4 square root of a minus 8. Now, before I do all that, let me look how complicated that became, right? What if I left it? Look what I've got up here, a minus 4. What if I left that thing down there, in brackets, right there, and it's being times square root of a plus 2. This, imagine if that just said 7. And that just said 7. It would be easy to see that they cancel out, right? Because it's a number times something, and just a number up here. Well, this is the same thing. This whole thing in the bracket exists in a bracket down here that's multiplying something. So these can cancel out. And you're simply left with 1 over the square root of a plus 2. So before you expand, watch out. Watch out to see if a bracket up here matches a bracket up there, as it did in this case. Because that's usually the trick. So boom. Let's do the other ones, because they probably have the similar trick. Now, that's another thing about math. There's a reason why they're asking us this. Okay, so we're trying to get rid of the denominator. Now, this looks trickier than it is. You might be tempted to change this plus in here to a minus. But this whole bracket, this whole thing is inside that square root. So you leave it exactly as it is. And the conjugate here is just plus 2. And then you've got to and it's got to be over itself. The conjugate must be over itself. You might say, what? Well, inside the square root, when it's inside the square root, you just leave it as exactly as is. It's the subtraction of a number outside of the square root that we're looking for. So we know that multiplying conjugates, it just becomes the square of whatever's in that square root. It'll just become the number. So when these multiply each other, it simply becomes x plus 4. And then it's going to become minus the square of the second number, which is 2 squared. Well, what's x plus 4 minus 4? It's just x. You see that they're already trying to get tricky on us. Now, again, before I multiply out my stuff in the brackets, and that's why it's always good to treat the things like they're in brackets. You'll notice that you have x times this entire thing in a bracket. With x up here, well, they cancel. You're just left with x, square root of x plus 4 plus 2. And whatever you do, don't add these numbers. That's a square root of 4 added to the x. And you might say, well, can I bring the 4 out as a 2? No, because it's being added to this x. Those are married. You can't square root things that are being added together unless they both happen to add up to something. And x plus 4 doesn't add up. So this is the simplest format. X plus 4. It cannot be square rooted. And you cannot add the 2 inside to the 4. Just doesn't work. You can only add numbers that have the same base. And this is a square root 2 times 1. And this is 1 times this square root. So it's like having x plus 2. You can't add them together at the bottom. This is the simplest form of that. The reason they did it was so that you could practice canceling out. So obviously there's going to be a trick to this one as well. And again, I want you to just tell me what the conjugate of the top is. You're not going to change the symbol inside the bracket. You're only going to change the symbols outside the bracket. So we're multiplying by 1, but what's the conjugate? The opposite sign right here. So I know from conjugates, it's just going to make that square root disappear, and then it's going to be minus the square of the last one. Now, obviously, x plus h minus x squared, they're all different, so there's nothing the same there. So ultimately, once we remove the brackets, it's just going to be this. Okay, down at the bottom, a little bit more complicated. You're going to have x yeah, there's no way to extract an x from that. Like if this had an x in it, I could cancel out an x, but there's no x in it. Down at the bottom, I'm just going to have x times the x plus h square root plus x squared. And you might be tempted to say, oh, well, I can cancel here. No, you can't. They're being subtracted and added, not multiplied. No cancellation allowed. Now, there's probably a trick I'm missing. If I look at the conjugate x plus h, and then I'm going to get minus x squared. There's no way to take an x out. There's no cancellation possible. Maybe I missed something, but I don't think so. I think they're trying to trick you into canceling something that can't be canceled. Or maybe they're getting used to limits, because often in limits, as h approaches 0, is our goal. But there's nothing that's happening here that's in common. If this had an x in it, different story. But it doesn't. And don't get into complicated things where you think that square root of x plus h times square root of x plus h is x squared plus 2xh plus h squared. No, that's not how it works. A square root times itself just gets rid of the square root, and it leaves whatever's in there is what that becomes. That's all that this becomes. It does not expand. That's not what's going on. The square root being squared, essentially they just cancel each other out, and you're left with what's in the bracket. I do not believe this can be simplified. Perhaps I missed something, but I don't believe I did. You might want to check your back of the book for that one. And there you go.